Well, it's been several days. It worked for a while, but now the problem's back. I got the radio plugged into power mains. I turn it on, turn up the volume, nothing. The memory's keeping fine. The batteries are here, and this is the wire that maintains the memory. So it's been no problem with the memory, fresh batteries. But if it's plugged into mains, it won't. After a while, it won't work. Now I got the regulator hooked up to the meter, and we are pushing exactly what we had set it for, just a hair under 6 volts. It should be 6 volts exactly, but it's so close it wouldn't matter. There are things that get hot in here. I rechecked it with my FLIR camera adapter. This is always very hot. This relay over here is hot. That's the relay that switches between mains and battery for powering the radio. But if it's plugged in, that radio, that relay is on. If I leave it plugged into mains, this will happen after several hours. I go to turn it on and nothing, and that's because some of these components are hot. This transformer's hot, that relay's engaged and it's hot, and over here this relay is actually running all the time. It's actually sticking out 6 volts even with the off. It's currently off, but the regulator is still running. Now this is the regulator that was pushing like 8.5, 9 volts, even though it was a 6 volt regulator that we replaced. So now it's regulating properly, but something else must have gotten damaged by that. And I did take some air duster, tilt the can upside down, spray a lot of the components that the FLIR said were hot to see if bringing the temperature down would cause, and that didn't help either. So it's not something that's just straight up overheating and causing a problem. It's something that has some sort of more systemic failure to just being plugged in and not running. So now we check voltages. We know the voltages are good here, so we start checking other voltage points to see, well, are we losing voltage someplace? And that's the next step. Well, I was hooked up to the isolation transformer running off of mains, off my isolation transformer, and as I was checking voltages, everything seemed pretty decent until I got, let me zoom in, when I got to this amplifier. This is a quad amp chip. It didn't have voltage at the pin that I'm hooked up to. You can see I'm hooked up to one pin. This is the VCC in, and it's supposed to be 6 volts to up to 36 volts it can take per the data sheet, and it was 0 volts. Well, as I was probing and I turned on my meters to record min-max, for some reason, as soon as I went into min-max mode, that chip started working, but not very well. It started getting voltage, is what I should say. So you can see pretty much what we're testing here. So over here we're hooked up to the regulator, which is showing right under 6 volts, and over here we're seeing what's actually going into the quad amp chip, the VCC. I can turn on the music now, and it is working, but this clearly is not getting the 6 volts it needs. Now, interesting enough, I can put this into min-max mode and min, so if you looked at the meter here, you'll see it says it's in min-max, and it's currently showing the min value. I can cycle through that, show the max, the current reading, and the min. Well, that's the max, and that's the min. Okay, so you can see this is definitely working fine. If I come over here, you automatically see it fluctuating. I'll go into min-max, and it's recording the current value plus the max, plus the average, plus the min. And you can see the min dropped down to 3.5 at a few times. It's actually, and there, it just dropped down to 2.7. And if you're listening to it, it'll start to brown out. It actually, like, you have to turn the volume up to hear anything. And then completely goes out sometimes when it goes down to like 1. But we'll listen here for a second, and you'll hear the audio cut down when this drops like down to 1 volt.
Safe call was made. Padres challenge. He single back up the middle of the plate. The final 2 runs of the inning to make. Hit the ball to Brooks with the bases loaded in the 2nd inning, and his throw to the plate was wide. Charged with the first.
We had another little skip there. Well, it didn't actually go down to the point where it totally cut out the audio, but the audio did skip a few times when it went down to 3 volts. Now, the object is this this op amp has to have about 6 volts or really darn close, or certainly as close to our regulator as possible. I could bump up the regulator a little bit, but that's not going to save it. When this thing's dropping down to 2 point and 1 point volts, and the regulator's not dropping out, because I got this set to min right now, and you can see the regulator is not dropping out, but the voltage going to the op amp is dropping out. So I got some problem between the regulator and that quad amp. That's not only currently dropping the voltage too much, it's cutting the voltage out. Now that could be a bad capacitor or something else. But what I'll do is I'll start back tracing what's supposed to be providing VCC to that chip, and somewhere between that chip and this regulator we're going to find a device or a bad connection. A device that's bad or a bad connection. And then this should be very close to this value and stable, just as solid. That's solid stable. This should be solid stable at that VCC. That's our goal. If we can get that, then this is now fully fixed. So why are we having voltage problems? Here's the regulator that seems to stay solid. Even on min, it doesn't drop out. So either something's loading down somewhere after this and not affecting this, or something's interrupting ability to get the VCC, the 6 volts here. Now the output of my regulator that's been fixed here goes down to the yellow, and it has to go through some devices to get over to the VCC here. And if we flip over the board, the regulator's coming out right here. This is the yellow. Let me zoom in on that a little bit. So this is the back of the regulator pins. This is the yellow. It comes out here, and this is a jumper wire on the other side. You'll see there's just a solid wire between these 2 points on the other side of the board. Then it comes down here, and there's another jumper to here. Follows this trace over here. Notice this bit of corrosion. I'm suspect of that. I chipped off some of it already. It runs around the outside of the board here, up around here, and then into these 2 points. Now from here there's a 100 ohm resistor, jumps over top of essentially this trace, jumps over that, goes to the plus side of an electrolytic capacitor, comes over to a 0 ohm resistor. That means there's just a jumper to get over top of the trace that goes underneath it, so it jumpers over it and then goes right to here. Now this is the VCC of our chip. This is the dual inline chip here, and we've got, counting backwards, here's 1, 2, 3, 4, and that is our VCC. This is what's we've been metering as low voltage. This won't cause a problem. This capacitor could be could have a high, could be draining to ground. It could be, because there is a cap there. This is a 100 ohm resistor, so there's a small drop there. That's odd that they would do that. I don't think I'm reading that wrong. But ultimately, let's just do a trace of that. Let me zoom back out. So we have our meter set up in buzzer mode, and we're just going to buzz this out. So you should hear buzzes. So if we start on the regulator here, and I'm just going to follow that path I just showed you. I'm just going to, so that's good. It jumpers across here. That's good. Follows down through here. Of course, that's good because that's a solid trace. Jumpers across another jumper wire here. That's good. Comes along this suspect spot. Comes around here, up here, and here. And notice it did beep for a second, and now nothing. So why would it? That does make me think that maybe something's not right. And I'm pushing really hard, and I'm getting nothing. So something's broke along this trace, probably this spot. I'm going to clean this up and see if that helps. Now I did chip off that, and that's basically some celastic that's from a capacitor on the other side. It's not a leaking capacitor, it's just the stuff that glues a capacitor down. And if you get in real close, and I can get closer with my camera than I can my own eye, you can see that's not just more of this. This is just glue, but it's probably a slightly acidic glue, and that's dissolved, or basically heated up and melted around off of the capacitor on the other side. It's not from the capacitor though. But you can see it's almost completely through, which was probably causing all my other problems. Yeah, the trace is eaten right up to the edge there. There's just a sliver left. Almost enough to where it'll work once in a while, but then once this little sliver of a trace gets a little warmed up, then that's going to basically make an open there. So what we need to do is make a little bridge from good solder or good copper to good copper, and then we should see our full voltage back and a good continuity. And so from this side you can see this is the Celastic or glue that they used. They just throw a bunch of glue on these so these capacitors can't flop around, and if you're carrying around a radio like this and these capacitors, these heavy ones, flop back and forth, they'll break their solder connection. So that's what the glue is on these bigger ones for. Well, unfortunately the glue is gotten hot over the years and changed its characteristics and kind of flowed down and around, and it seems to be highly corrosive to, well, I wouldn't say highly, but enough corrosive to damage the trace on the other side. And this might have caused the regulator to be strained and kicking on and off all the time, and might have caused the other regulator, the one that I replaced here, that was pushing out 9 volts when it should have been 6. It might have somehow caused it to get, you know, damaged. But now this is good and solid, putting out nice, well, really right at 6 volts. And if this trace is fixed, then this op amp will get its proper VCC, and this should be 100% repair. I won't show the repair of this. I'm just going to scratch this solder mask, the green solder mask. I'm just going to scratch it off on either side and put a jumper across those two. It is just a little flux to make it all a little cleaner solder job. No clean flux. I have a link to it. I think I have a link to it on my Amazon page at toddfun.com. I don't know. I'll have to put one there if I don't. It's messy, but it'll make for a better solder joint. There, the flux makes it flow real nice. Just got to make sure that the back of this doesn't short on anything, and this is all plastic back here, so I don't have to worry about that protruding. If I had to worry about this protruding, and I would put some tape over that or coat that with something to seal it good. And so the test would be, do we have good connection from the regulator? If I did my solder correctly. Yeah, over to here. Yeah. Nice and solid now. Right. So that's a real good connection now. And that will fix our problem, I think. It says no cleaning. You don't really have to clean this solder or flux, but it just really means it's easier to clean. So a Q-tip will get that residue off, and it's always good, even if it's no clean. It's just really easy to clean is kind of what I would say, but I still clean it up because you don't want this corroding or causing any other problems in the future. Plus it takes this gooky mess off. And because that glue was clearly degrading and causing, it was basically corroding copper traces on the other side of the board, I took a few minutes and just scraped it all out of there. So no more of that Celastic glue will continue damaging any traces on the other side of this board. So the board's back in with the fix and the trace. I'm hooked up to the regulator again with this one, and the VCC on the quad amp amplifier chip is this meter. Let's turn on the isolation. This is my isolation transformer underneath the meters. I'll turn that on, and even though the radio is not on, you'll notice that the regulator kicks on, and we're getting 5.8 volts at our VCC now. Whereas before we weren't even getting much more than 4. Now there is a 100 ohm inline resistor there, so they're not going to match exactly, but still really close to the 6 volts. In fact, if I cared to, because this is an adjustable regulator, I could go in, change the resistors on the adjust pin, and bring this up to a bit more than 6 volts, and then this would be bang on 6 volts. But that's not going to matter. This radio is going to play at 5.89 just fine. And that trace is fixed, and it's clearly done there. Let's go into min-max mode here. We're solid at 5.8. We'll go min-max here. This meter's a little clumsier to use for min-max. You have to change it over to max and then min, and now we're worried about the min value, so now we're showing the min value. If there's any new mins, it'll pop up and beep. If there's any new mins, this will beep as well, but it's displaying them in order. These are sweet meters. Okay, so let's turn on the radio.
36 run driven into the year.
We got one little beep, so just the tiniest thing.
Kemp fouls it back, 1-1.
I think we're getting a couple of ups and downs.
And their last 9 starts, 6-3 with a 2.25 ERA.
So incredibly stable now. So my problem all along was that trace. And this is solid. This is solid. This is no longer pushing out 9 volts. It's pushing out proper 6 volts. This is stable, so I don't even have to worry about this anymore. This is a final fix. If I had gotten lucky with the cold spray by using the upside down cold spray to make, you know, really cold dusting like that, if I had gotten lucky and hit that trace down there, it might have started playing. It might have changed the voltage levels. But because I was hitting chips and capacitors and other things, and I probably wasn't getting the bottom of that trace cold enough to cause that thin trace to reconnect, I could have found it with this, though. I might have gotten lucky. So never forget that little trick for finding intermittent circuit problems. But I'm going to go ahead and put the radio back together and use it for a few weeks and report back in just a few seconds to you whether or not it for sure is a solid fix. I'm sure it will be. And I'll probably throw in the charging circuit back into this compartment because it's nice to have the charger there. Being it wasn't a problem anyway, I do still have it. So back in a few. Well,
with the lowest price anytime.
It's working. It's always working. It's been about a week now. I've been playing the radio. This DeWALT's been playing for hours on end in my garage. I've had it off and plugged in and not playing. I've had it on just batteries. I've had it pretty much every configuration, including playing auxiliary, AM, FM. Everything's working fine. So that was it. That was the fix. That celastic material, the glue, if you will, it just corroded the trace. So if I were going to say what I would like to bring from this as a learning experience, is that, yeah, the FLIR attachment was kind of helpful to see hot spots on something that was just plugged on and not running. It let me know that the device is actually using a lot of energy just plugged in, so I won't be leaving it plugged in anymore. But it didn't really help to find the actual problem. It did find that overloaded, or I should say a failing regulator, but ultimately it wasn't going to show that bad trace. So it really just comes down to knowing what voltages should be and where on the board and checking to see if they're there, and not just there, but are they stable, are they fluctuating a little. So by seeing, by looking up the pinouts on some of the ICs and some of the devices, looking at some of the traces, looking for test points, you can find several voltage points that have to be known. You know, if you know what a chip needs, 8 to 6 to 15 volts, well then you should see that, and it should be stable. So in this case, knowing that regulator was 6 volts, I really didn't need a FLIR to see that it had an issue, because a regulator is going to be warm anyway. But by just testing the voltage output, it would have known, hey, that voltage regulator is having a problem. Likewise, by just testing the voltage points at some of the chips, in this case the quad amp VCC, sure, it might have had, sometimes it might have been getting its 6 volts, but even then, because that trace was so bad, it would have been fluctuating, and that would have been a red flag that something's wrong with the power supply coming to that chip, and I could have started backtracking from that fluctuating power input for a device that was bad, and I would eventually found either a capacitor that had gone bad, or another device that has some intermittent short, or in this case a bad trace that was under temperature conditions making and breaking. So great lessons to learn. FLIR is a great tool. I still use it a lot. It's a really go-to tool for just knowing what's going on, just things you wouldn't otherwise know is happening. But ultimately, check your voltages. Thou shalt check your voltages. Learned that from Dave Jones. Not that I didn't already know it, I just didn't have the saying. But, oh well, everything's fixed. I think it's a perfect fix. I think it's a great fix. Hope you learned something. Thanks for joining. Give me a thumbs up and let other people know that hey, this is a place you can learn some stuff. Oh, we have a dog barking. Oh well, I'm out of here. I gotta go see Ted 2 because, you just can't miss Ted 2. Bye.